they're equal. So we can say that the square root of 25 equals 25 to the 1/2 power. All right. So what we're going to do today is we're going to, we call it rational exponents. Okay, we're going to kind of go back and forth between radicals and exponents. Okay, and our formula looks like this. Our formula looks like A to the top over bottom equals, the radical form is going to be A to the top bottom. Okay, so we're talking fraction form. The real formula is actually A to the m over n equals A to the m to the n. But I think it makes more sense when we're talking top and bottom of our fraction. I know it's not using the correct vocabulary, but I think it makes more sense. Okay, okay? Alright, so using that, we've already talked about this. Using that, alright, this would be 125 to the what power? Well, no, to the, this is 125 to the first power, right? Okay, so if I'm going to change this to a fraction, it's going to be 125 to the 1 over 3. Which is, put that in your calculator. Spencer, throw me yours once, so I can show you guys that. This guy, your fraction, needs to go in parentheses. So, on this guy, it's going to be 125, and then use this fraction key, the funky little upside down V, and then it's got to go in parentheses. 1 divided by 3 parentheses, we get 5. Does that make sense? All right, so use your parentheses on these guys. So 125. And then you're using this button. This is your exponent key. Oh, okay. So yours is the y to the x, I think. And then you've got to go parentheses, 1/3 parentheses, and then equals. So what did we get? 5. Anybody else have any calculator issues? All right. So what did we say? This is called the what root? Square root. Okay? And so if there's nothing out here, what did we say our imaginary index was? A 2, right? A 2 on the outside. There's an imaginary 2 out there. So this is 36 to the 1/2, which gives us 6. Okay, this guy is 32 to the 1/5, which gives me 2, good. And 64 to the 1/3, which is 4. Okay. Questions about where we are coming up with those numbers? Okay. Use those formulas. Okay. Alright, so now we have variables, right? So when I'm using variables, things are going to be alright, so now basically we're just not going to be able to simplify. So we're going to have s to the 2/3 inside over the outside. Okay? If you have parentheses, it must stay in parentheses. So 4y to the what's on the inside? 5 over 2. Because remember, if there's nothing there, that is an imaginary 2 because it's a square root. And if I square something, it's to the what power? Second power, yep. Okay? Alright, if we are looking at this guy, is my 12 underneath the root? No. Okay? So we're just going to leave him be. We're just going to bring him down to 12, and then x to the 4 thirds. Alright, this last one, is it in parentheses? No. What is it? It's 256 to the what power? Just to the first power, right? Because there's nothing there, and so that's just an imaginary. So I've got to do this two different ways. 256 to the 1/4, a to the 8/4. All right, so now let's do some simplifying. 256 to the 1/4, 4, and then what is 8/4? So my final answer is going to be 4/8 squared. Okay, anytime you have a fraction that you can simplify. Okay? All right, so I want you. Okay, everybody do the first one. Isaac, what'd you get? A to the 3/5. Good. Okay, everybody do this one over here. This is the one you're working on now. Devin, what can't I forget in this one? The imaginary 2 and the parentheses, right? So 4g to the 4 halves. All right, can I reduce that 4 halves? Yes. So 4g squared. And then if I use rules of exponents, what else can I do with that squared? I can distribute it, right? And I can get 16g squared. I would be okay with this answer at this point. Okay? But let's get used to getting it down as far as we can, all right? This one, what do you do with the -3? You left it alone. So we have -3 and then x to the 5/4. Very good. Spencer, have you done that last one yet? All right, so you got 256 to the good. The 1/4 a to the 3/4. Is there anything I can reduce? Yeah, my 256 to the 1/4 is 4. So 4a to the 3/4. Formula? Not so much. Okay, but we do have to look at, sometimes they're going to give us the x, so this is our formula, remember. We just kind of simplified it when we went top and bottom, okay? But this is our formula. So now we're going to take our exponent and change it into radical form. Okay, so if you remember, we've got root of a to the top, bottom, or the denominator is going to be my index. So this is going to be a to the 5th, and what's my index going to be? 6. Good. Okay? This guy, my 54y has to do what? My 54y has to be in parentheses. If they give you parentheses, leave it in parentheses. Okay, so 54y to the second power, my index is 3. Now be careful, because some of you, your index is kind of looking like a coefficient. Okay, make sure that it's just a little number above your radical, not completely out in front of your radical. Okay? How about, what do I do with this 5? Huh? Put it on the outside, yep. So 5, my radical is going to be x to the first. So do I have to put my 1 there? And what's my index going to be? 3. So do you see why my index has to look like an index? It can't be a coefficient out there in front. And we got to be able to tell the difference between those. No, because the 5 doesn't have an exponent on it at all, does it? Okay, so then you know that you just leave it open. Okay, unless it would have an exponent, we had to do something with it. Okay? Good question? Alright. Let's look at this page, see what we can do with it. Done do that first one yet? You got a to the third. On the outside, your index is 4. Perfect. Okay, I have parentheses on the next one, so it's got to stay in parentheses. So I have parentheses 8b Skylar to the second, and my index is 3. Good. Reagan, what do I do with my 27? Good. Leave the 27 alone. I've got a to the second. My index is 3. Good. What do I do with 18? Leave it on the outside because there's no exponent with it. We're at b to the first, so I leave it. My index is